Hello everyone, welcome to today's class. In today's class, we'll be taking a dive into how to solve a real world problem. So we will take a problem, break it down, write a program, and see how all of this comes together with what we've learned so far. Alright, so the program says that a program is required to prompt a terminal operator for maximum and minimum temperature readings on a particular day, accept those readings as integers, and calculate and display to the screen the average temperature calculated by the formula given. How do we solve this? First, let's start our IDE. Alright, so let's click on create new project. Can everybody see my screen?
Yes, sir.
All right. So click on console application to create a new console application. Let's move to next. And next. And then the title of the project will be average temperature. All right. So let's call it average temperature. All right. So once you create a project like this, you double click on the main.cpp. That's our main file. That's where our program will sit. You'd see that you have something like what you see on the screen. So this, like we saw from last week, this is just a code that is generated for us by the compiler, but it gives you a template to work with. Most of the time, it is how your project would look like. So just before we go on, and again, this is captured in the video that I shared. So take time, go through that video. And then if you haven't subscribed to the channel. So the first line that you see, include IO stream, is just a derivative that is added to your code. This is what tells your compiler you intend to use the input output stream. The input output stream is what helps you to be able to receive inputs from your keyboard and then display your outputs to the screen. And so that's what the first line does. So whenever you intend to receive inputs from the keyboard or display outputs to the screen, then you need to add that derivative. And then we also have the namespace std. Namespace are just a way that C++ compiler organizes files so that you don't have what we call naming conflict. So sometimes you may give a name to your function, or a name that you may use may conflict with another name that has been given to a function already. You understand? But the namespace organizes your file such that these conflicts are minimized. So if even the names are the same, but they are sitting in different spaces, then you will not have that conflict. And then after that, you see that on line 5, we have int main. The main is the name of the function, right? And so once you see int main, this is the name of the function. It's just telling you that you are within the main function. So the name of the function is main. And then it is a function, that is why it has the opening curly brace and the closing curly brace. Some functions take arguments. So we'll study what functions are later, but just know that there's something called functions. And some functions, you can pass arguments to them. So when you need to pass argument to the function, argument will come in between the opening and the closing bracket after the name. This one doesn't take any argument, and that's why we have the opening and the closing bracket, and then there's nothing in it. And then why do we have int? We know that int is a data type, but int before the name of a function tells you that after the function has finished working, it is going to return an integer. And that is why after we have finished writing all our code, the last line we write return 0. Return 0 means that we are returning an integer after the execution of this function. And so if you have any errors before the return 0, then this line will not be rich, and so it will not return that 0. So you would see that once it doesn't return an integer, we automatically knows that the function did not execute successfully. I hope you understand. All right. So, in today's lesson, what we are going to do is the assignment that was given last week. We are going to solve it together, and then it exposes you to how to tackle some of these problems when you meet them in real life. So let's look at the question. So the question says that, let me right. The question says that a program is required to prompt a terminal operator for minimum and maximum temperature readings on a particular day, accept those readings as integers, and calculate and display this to the screen the average temperature calculated by maximum temperature plus minimum temperature divided by 2, right? So this is what uh, the question is. How do we solve such a question? So typically, when you meet a question like this, and again, remember that I said you should watch uh, my videos from the principles of programming. That will tell you how to tackle a problem like this. When you meet a problem like this, how do you tackle it? So first, you look at the question, and then every program goes through three processes. It receives input, it processes the input, you an output, right? So when we have a question like this, what we first need to do is to first identify what the inputs are. So, but let's read the question again. The question says that a program is required to prompt a terminal operator for minimum and maximum temperature readings. So in this case, then what is the input? So you can see from the question that the operator is being prompted to provide minimum and maximum temperature reading. So this is what your program is expecting to receive from the user. We are referring to as input, right? So now what we are going to do is to write down the inputs, right? After writing down the inputs, now let's identify what the outputs are. And so when we continue to read, we will see that the output that is expected from us is the average temperature, right? But remember, we said something from last week. Whenever you are receiving an input from a user, those inputs do not hang in the air. So you have to create a container to receive the, right? Now we have just seen that we are getting two inputs from the user. One of the inputs is called minimum temperature readings, and then one of the inputs is called maximum temperature reading. So let's create two containers. One thing that we also saw is that whenever you are creating a container, label that container so that you can easily remember what you kept in the container. So if we are going to store a minimum temperature reading, then let's call our container minimum temperature, right? So let's type minimum temperature. That is the name we are giving to our container. So let's shorten it. Let's do min underscore temp, right? So we'll use this to represent minimum temperature. But remember that we said anytime you want to create a container, you need to tell your compiler what type of data you intend to put into that container, right? So that your compiler will select the right container for you. So for instance, if you do not tell the compiler that you want to keep an integer in it, the compiler may give you a container that is not appropriate to store integers, right? So let's assume that the input that the user is going to give us is going to be what? Whole numbers. So let's tell the compiler that we intend to store an integer in min temp, which is the name of our container, right? So let's put int before that. All right. So this is how we technically call like this thing that we have is technically called declaring a variable, right? So we telling the compiler that create a container for us, the container we intend to store integers in it, and then we have typed it down this way. Int main. This process, let's terminate it with a semicolon. So in C++, anytime you finish typing, right, a full sentence, you terminate it or you end it with a semicolon. So now we have said that int underscore temp, meaning that we intend to create a container. That container should be called main temp, which is a shortened form of minimum temperature. And then we install integers in there, right? So int main temp, that is, we have declared a variable called minimum temperature. Now let's move to the next line and then let's declare a variable called temperature. So the same process, we'll type main and then max underscore temp, right? So now that we have received, created containers that we'll use to receive the the two temperatures, right? Let us go back and see what else we remember that we broke our program into three main components: what we are receiving from the user, what we are supposed to do, and then what we are giving out to the user, which is our output. So the question says that after we finish calculating, we should output something called average temperature, right? So that average temperature is also data, so value. So we have to put it in a container. So let's create another container that will hold average temperature. So we'll go to the next line and then we'll do int and then average temperature. So now we've been able to create all the containers that we need for this program. After creating all the containers that we need for this program, we will go back to the read again. What do they expect us to do? We would see that the program says what? We should accept, we should prompt. This is that the program is required to prompt the terminal. Prompting is just issuing a command to your right, telling the user to do something. And we know from our last class that whenever we want to display something to the screen, we use a keyword called what? Cout. So if we want to tell the user that please enter min, then all we need to do is to type C, then a double less than. And then because we want to display the text as it is, we'll put it in quote and say that please enter minimum temperature. If you have any question, you can raise your hand. I'll call you and then you ask your question. And just for it to look presentable, whenever we finish issuing the command, we want the cursor to move to the next line. That when you type in the value, that value will be on the next line. And so that's why I ended it with the end line, right? So after telling the user that please enter minimum temperature, we are expecting the user to enter something. So we have to receive whatever the user is entering. How do we receive? We use what we call, right? So let's move to the next line and then say that C in, and then this time note that we are using what? A double greater than, not a double less than. So see the difference between the operators that we are. First one is a double less than, the second one is a double greater than. And so we are receiving, so we say C in. What container are we into? We expect the user to the minimum temperature into the container main underscore temp. So it will be followed by that container. Okay, so what we have written down simply means that receive whatever the user enters into the container main underscore temp. I hope it's clear. Yes, Frederick.
Yeah, say, I was thinking when you put the using namespace, you don't have to write this the EMDL at the end of the enter minimum temperature.
No, that is not correct. When you use minimum space, using namespace std, you still have to write that if you want to move to the next line. Do you understand?
Okay.
Yeah.
Yes,
But
sir.
if, for instance, we had not used using namespace std, then we cannot type a keyword like see out. Then we have to now bring std, then colon, then see out. You understand? But when we
Yes,
tell
sir.
the compiler that using namespace std, then we mean that all the functions that we want to type here should sit within the standard library. And that's why we don't need to type std colon c out. But if you want to move to the next line, you still have to use the end line. Is it clear?
Yes, sir.
All right. So let's move to the next line. So we will leave one space, yes. And then now the second, remember that we are expecting two inputs from the user, right? We're expecting two inputs from the user. So the second line is what? We'll look at the second line that says that uh, we should prompt for the maximum temperature. We've been able to prompt for the minimum temperature. So we now need to prompt for the maximum temperature. So we'll do C out. We repeat basically the same thing. C out, please enter maximum temperature. And then again, we want the cursor to move to the next line. So we'll end that with the end line. Then once the person enters the maximum temperature, we want to receive it. Remember, this time we are not receiving it into the container main temp. We want to receive it into the container max temp. So let's do that. C in and then max temp. Right. So what this does is that the second number that is entered by the user will be put into the container maximum temperature. But we're given a formula. In the question, we're told that anytime we want to we want to calculate the average temperature, it should be the minimum temperature plus the maximum temperature, all divided by 2. So let's type the container that we kept the minimum temperature in. Right, so minimum plus maximum divided by 2. All right. So the reason why we put minimum and maximum into bracket is just simple what we learned from our mathematics class, board mass. We want the addition to happen and then the division should happen later. And so we know that when we put something into bracket, it will calculate that first, right? So we want to simply do minimum plus maximum. Once we get the value, then the value will be divided by 2. And that's why we put it into a container. But when we divide it by 2, you notice that we have what? We have another data that has been generated or another value has been generated. Remember that I said anytime a value is generated, we need to put that value in a container, right? So we assign the new value to the container average temperature. So when we say average temperature is equal to min plus max divided by 2, all we are saying is that add minimum temperature to maximum temperature divided by 2. The new value that you get, put it into the container average temperature. So the equal sign here is what we call the assignment operator, right? It is used to assign, it is used to put value into a container. And so that is what we have. And then after this, we can simply go to the next line and say that now display, let us display about the average temperature. All right. So then now we display the average temperature and move to the next line, right? So let's run this program and then let's see what. All right. So you see that it says please enter minimum temperature. So let's enter a value. Let's say 10. Right. So let's enter 10. And then the maximum temperature, which is 20. All right. So can you see that we now have what? The 10 plus 20 divided by 2 is 15. So the average temperature, sorry, the average temperature is what? Is 15. Is it clear?
Yes,
Yes,
sir.
sir, it's clear.
Okay. So this is simply how to go
And
through.
no percentage. At,
No, why do you need a percentage? It's your average. The average is just a number. I believe it's clear. All right. Do you have any questions? Any questions?
why do we leave space before going to another one? Sometimes we leave two space, sometimes one.
So again, when you go back to the video that I referred to you on YouTube, you would notice that I mentioned something like spaces do not actually have any effect on your program. You can leave 100 spaces, it will still not affect any program. The reason why we leave spaces is just for it to be readable by you, the human being. The compiler doesn't care. If we can write all of them on one line, the compiler will still execute successfully as long as we terminate them at the right places. You understand? But for us to be able to read it easily, that's why we leave space. So if you look at the way the code has been organized, you see that your variables are on top, then we leave a space, then your first action, you prompt and receive, and then we leave another space, you prompt and receive, then we leave another space, you do your calculation, then we leave another space, then you display your results. So this has been organized so that you can easily follow what we are teaching. I hope you understand. But then
Yes.
the spaces does not have any effect on your program.
Okay.
Yeah.
Please, what if the average temperature becomes a double?
If it becomes a double, so that's why you are the programmer. So if you are writing your program and you know that, okay, there's a possibility that the average temperature becomes a double, then it means that you need to declare your container to be a double, right? That's why before I started declaring, I said, let us assume that everything that we are going to handle, it's what is an integer. And that's why we declare this as what? As an integer. But if you're expecting a double, then you need to tell your compiler that. So instead of maybe min temp and then max temp being what? Being integers, you declare them as double. So for those of you who are a bit confused, when we are talking about double, we are referring to numbers that has fractional parts. So maybe 1.5, 1.7, right? The way 1.5 is handled, the container that is needed to store a number that has a fraction behind it is different from the container that is needed to store a number that is a whole number, right? So once we say int, it means that we are expecting the numbers to be whole numbers. But if you are expecting the numbers to be fractions, then you change from int to what? To double. Is that clear?
So what about using the float?
Again, comes back to the same question. Selecting the container that you want, or selecting the data type, if I want to use the right term, selecting the data type that will fit depends on what you expect from your users. You understand? So you as the programmer you have a lot of control. It is your program. So you need to determine this program that I'm writing, should this be am I expecting users to give me this type of data? Or am I expecting users to give me that type of data? This is what is going to determine what type of container you are going to select. You understand? So choosing a data type, whether it is int, whether it is float, whether it is double, whatever it is, it depends on what you're expecting. And again, it also means that you need to get a deeper meaning, a deeper understanding of what the different data types are. For instance, float is used to store fractions. Double is also used to store fractions. So the question will be, what is the difference between a float and a double? It depends on the precision, the number of digits that can come behind the decimal numbers, right? For instance, your float can take, I think, about 7 digits, right? And then double can take about 15 digits. So depending on what you expect, if you expect that, okay, I'm just going to store the averages of students or the marks, the scores of students, then you know that you're not going to have a lot of digits after the decimal point. So you select float. But for instance, if I'm going to store some kind scientific calculation, then it is very possible that the number of digits behind the decimal point can be very large, and so I have to use double. Do you get a difference?
Sir,
Yeah.
so what is the static cast for?
When we say you are casting a number, or when you are casting a value, basically what we are saying is that you are trying to convert that value from one data type to another. So for instance, if I do my calculations, I've used integers here. I just suddenly realized that, oh, this uh, numbers that I am using, these integers that I am using, it is possible that when I find the average, it will become a double, right? And so I will cast the value into a double, meaning that I will forcibly convert that value, which I had originally declared as integer, into a different type called what? Double. So when you hear of casting, it is simply, basically, you are forcibly converting that value into a different data type. Any other question?
Sir,
Yes. Bright.
sir, please, can you add two data types together?
Can you add two data types together, as in a simple addition? Yeah, go figure. Is that, are you saying that, for instance, if I have a double and I have an integer, can I do a
Yes,
summation of
please.
the two?
Yes.
Uh, yes, it is possible for you to sum them together. But for instance, when you sum them together, then you see that it has to assume one data type. You understand? And that is why sometimes you have to cut.
Okay.
So for instance, if I have an integer and I'm adding to a double, then I have to cast the new value that is coming into a double, meaning that I have to, for lack of a better word, force and convert it to a double. Thank you very much for your time. I'm hoping to see you in another session where we'll do more exciting things in class. In the meantime, if you have not subscribed to this channel, please subscribe to get more informative videos like this.